today's session, we will really be looking at um, just the thoughts around coding and robotics in education, and the for it being a buzzword now in the education sector in all bands from grade R all the way through to university, and it's making a greater presence now in the schools section, the GET, General Education and Training, the FET, as well as the TVET sectors. So we're just going to be gathering some thoughts and around coding and robotics in education from our subject matter expert panel. And then after that, also their thoughts and ideas on coding and robotics within industry, within the current fourth industrial revolution and moving beyond fourth industrial revolution. So the panel of experts that we have sits in their different pockets and segments of the education sector. And they will be introducing themselves and then thoughts around coding and robotics. And then finally, we'll just be ending off with some closing thoughts and remarks.
My name is René Engelbrecht. I'm currently a teacher at a private school in Gauteng. My whole life has been around coding various languages. The robotics part comes in as kind of a hobby, and I started introducing in certain sections of the school during previous years. So the hardware together with the software now forms the robotics part of it. So that's where I am at this particular stage. So creating a bit of electronics as well around the sensors that goes with the robotics. But at the end of the day, it's all about a robot that has to take some commands and execute those commands. And that's where I'm good at the commands, good at the software. And I've been doing this for quite a while. That is my gist of what I am into at this particular stage.
Yes, thank you so much. Good afternoon, colleagues. I'm Tembiso Matonsi. I'm based in Vryheid. I'm at Mtashana TVET College. I'm a senior lecturer for NCV Electrical. So yes, I'm mainly in the field of electronics as well as electrical power.
Hello, everybody. Yeah, all my life I've been involved with electronics. So I first started in the industry where I did electronics and computers, industrial type computers. Then I went in 1994, I started in the college sector where I lectured all the NATED courses and then later also NCV in electronics. I also did the practicals at the college for the MASITA, Electronic Equipment Mechanician, where I set up all the phases. And one of them was also microprocessors, where I started with the PIC and then Arduino, PLCs, and later the Raspberry. Yeah, I'm still part-time at the college, and thank you.
Hi, everybody. So I am Department Head of IT at Parkview Senior School. For the past 25 years, I've been working in IT, teaching IT to children from grade R all the way up to grade 7. I've been involved, I'm an IT technician as well. I've been involved in the field, and it is incredible to see what children can achieve when they are willing. And currently I'm doing coding and robotics. So the children are loving the move from IT to coding and robotics, especially the younger kids. They love coding.
Everybody, I'm Shani Nankumar. I am with the KZN Department of Education. I have served as a teacher of computer studies way back. So I come with the history of basic, Pascal, Java, Delphi, Python. So I lectured at the Springfield College of Education in computer science. And when the colleges were closed, I served as SES, which is subject advisor for IT and CAT, and currently I am DCES for IT and CAT in the Ilembe district in KwaZulu.
Good day. Yeah, I'm Brian Dole, and I'm at a high school in Cape Town, in the northern suburbs of Cape Town. Have been an information technology teacher for many years. Also previously a CAT teacher. So a background in Java programming, Delphi programming, Python, and we are also now one of the pilot schools for the Coding and Robotics syllabus in grade 8. So that's also very exciting to be involved in that. And yes, and like Rainier, the robotics side has been very much a hobby that's now turning into a reality as part of my work. I think, yes, we, as I said, we are one of the pilot schools for the new Coding and Robotics syllabus for the GT phase in high schools. And I think one of the challenges is the range of devices that are available out there, and making the right choices. And it's quite difficult if you haven't worked with all of them to decide what is right for your school, what's going to work there, because you might find yourself going down one route and running into limitations and realizing that perhaps you should have chosen something else that's more advanced. For example, the material that we have at the moment is written basically for the microbit. But there are more complex devices out there than a microbit. But the children enjoy working with it very much. So they love experimenting, getting hold of the devices. They go within a few minutes, they go beyond what they're supposed to be doing because they enjoy it so much.
Okay, so I would take it that from the excitement that students get, because even from these pictures, which are simple pictures that you will find when you Google coding and robotics, there's a lot of moving parts, tangible parts that could get students quite excited to go faster than what the lecturer is currently going in terms of just introducing something, and they want to know how this works. Like just a kid at Christmas just unwrapping a gift and going for it?
Well, for me, I personally feel the more excitement there is, the better.
Okay.
Because your very best way of learning something is to discover it for yourself and to go through that problem solving. If you have been given a challenge and you told what you need to build and what this robot needs to do, it is amazing the amount of different kind of stages of problem solving that you need to go through, how the learners go through this and the students go through this without even seeing it as work. It's a challenge. And so that for me is very exciting, that they learn on their own so much.
We can divide what we are using in this syllabus and what the schools and the TVETs are going to use. We can divide into two parts. The first part is what we call a microcontroller, and the other one is what we're going to call a single onboard computer. So those are the two. The microbit falls into the first part. The Raspberry Pi will fall into the second part, which are very small computers. I mean, it's the size of a hand, which we can have. Even with the Arduino, which is smaller than the size of a hand. So that's also a microcontroller. And because of the Arduino being open source, people have taken Arduino and they've made different parts to it. So there are a lot of different Arduinos that you can even buy. So people would just need to make sure when they buy the Arduino that they buy something that is part of the syllabus or part of what they want to do. Because each one has got his price, to be honest with you. You get from the small cheap stuff to something expensive like the the Raspberry Pi, which is one of the more expensive hardware types out there. So for our purposes in education, we've focusing on one of those two, to focus on the Raspberry Pi. Now, the reason why we're wanting to use this particular type of Raspberry Pi together with the Python is to introduce them. A very gradual introduction, or an easy introduction into hardware, software, and coding that particular piece of hardware, because each and every hardware kind of codes slightly different sometimes.
Okay.
That's where we are currently. We want to say, you know what, let's start off with the Raspberry Pi, with Python. The two are practically married to one another. Raspberry Pi and Python is just, you kind of, when you talk about Raspberry Pi, you talk about Python. That's how good they are together, those two. And it sorts out a lot of problems beforehand in introduction. Yes, we're going to go to Arduinos, to microcontrollers, and we're going to go to a more, or a bigger language, or a more complex language. But
Okay.
is very good for us in the way it has been set up. We start off with the Raspberry Pi, being it very easy and being married to Python. Python is a very easy language, and those two together, entry level, we can teach them around loops, around selection. All the complex concepts are not dumbed down, but are easier to understand if the hardware is one type and your language that you're teaching with is also a type. So that's why the Raspberry Pi and Python go so well together, because the Raspberry Pi is easy to program and Python is an easy programming language. So introductory level, wow, that will work great.
Okay.
Yes.
Awesome. So we can understand that that there are different hardware needs as well. And one specific hardware component being the microbit or the Raspberry Pi or the Arduino, each serving ultimately the purpose of being the core hardware element, but has different functionalities with different languages.
So it's very important, obviously, that every one of the students have their own computer that they can work with. Together with that is also very important that they have a good network that will support, and internet that will also support the computers. With that goes load shedding in South Africa, so therefore we need a good UPS to go with that. And then obviously wiring and things like that, when it's set up, we need to make sure that it's nicely packed away so the students do not get in contact with that. Also, maybe a USB port that is actually an extender that's put onto the desk with sturdy desks is very important, so that they can plug in their devices and plug it out without having to damage the main port on the board, on the computer board.
Okay. And that would definitely speak to allowing, like Brian Dull said, allowing students the excitement of exploring and just interacting and engaging with these components, but ensuring that they are secure and also, let's call it insured, in a manner that should excitement exceed certain components, vulnerability and sensitivity, that it can actually be handled. And like you're saying, it's on a secure type of workstation.
I think the software requirements, if you look at the school in general and maybe colleges, I've been involved with the GET, the grade 1, 2, and 3, and the grade 7 training. And I found that they need to know Scratch, but as you know, certain schools don't have the computers So they're going to be doing Scratch with coding cards. And with the grade 7s, they are going to use EduBlock with Python programming. So they're not just going to go into a text-based language. So they're going to drag the EduBlocks and they will see the equivalent Python code. So that is how the Python training is going to take place. But for Python, it is text-based, so it is not memory intensive. But for Scratch, I'm sure you need it's memory intensive, not as bad. Java is also not bad because it's not memory intensive as well, except if you're going to use the GUI system. Yeah, so I think Python will run basically on any computer. Scratch is free, so is Python. Microsoft, we on the Microsoft agreement, and I hear that we have now, Microsoft has now signed the memorandum of understanding, and therefore we will be topped up to 2019, which schools will get free.
And this is the Office suite.
The Office suite, yes.
Okay, yeah. And I'm also aware that they allow Office 365 for active students that are registered through their student enrollments.
You'll have, well, the most important one is obviously all the transducers, sensors and transducers that can be interfaced to the Raspberry or Arduino. Then with it comes other little components to signal correct it to make it to the right voltage levels or signal levels for the specific computer.
Okay.
Or because there is NCV electrical engineering at most of the colleges, all the colleges should have all the parts, they should have all the instruments.
Okay.
One of the subjects is also PLCs, so they need to know how to wire up a PLC and write a program in ladder diagram for that as well.
And just for me, what does the PLC stand for?
It's an industrial type computer process logic controller. It also just takes the input, acts on the input, and executes an output.
And then also just for cost perspective, for example, a multimeter tester, is it required that all students have their own, ideally, or are these equipment and components able to be shared and recycled among students in a classroom setting?
Yeah, because the components are very cheap, they buy it and then you can give it to the students, or you don't really want to reuse it, especially if they're going to solder it or they're going to build a little circuit and they might not do it properly the first time, so they blow these components up. But the multimeters, yes, we need X amount of multimeters.
Yeah.
Each student doesn't need a multimeter. He can just request he wants a meter now to test, and then the lecturer will show them how to test and they will do it themselves.
Sorry, I just wanted to ask Brian that PLC is just like Arduino on steroids. Am I correct? We can have it like that as an analogy?
Yeah, I mean, it's an industrial type computer designed for the environment of the industry. It's the most popular computer system out there in the industry when it comes to automation. You understand? Although I did teach first the PIC, then I went over to because I know the assembly language very well. That's what I was taught. And then I went over to Arduino, where my students actually built little Arduinos, designed the little layout, everything, and built it from scratch. I bought all the parts. And then we went big into PLCs. So we got full-on PLC labs. And then my hobby is also robotics. So I've also got the Alphabot and I learned a bit of Python, and I've got the Raspberry, a number of Raspberries as well, including the Pico.
Thank you so much. For personal protective equipment that is required, especially in electronics lab, it's a safety gear, which is an overall, as well as safety goggles may be needed when doing the drilling, and also face masks when we are doing soldering. So just that smoke is not good.
Okay.
It can affect the lungs of students. So it's vital that we have those safety things in place in the electronic laboratory. But the student must always, because also due to electrostatic sensitive devices, we've got ICs that are very sensitive to electrostatic electricity. So we need to have rest straps, and also the place should be done in such a way that it is free from electrostatic electricity, so that whenever students are, and also we should not use hands to touch components, especially those that are electrostatic sensitive. They need some special tools to handle them. So it is very much one of those safety precautions that needs to be taken into consideration, especially in the electronics laboratory.
And would colleges and schools have to ensure this already before students come in, or will students be expected to come in with their own goggles and their own pliers or equipment to handle the components?
With any industry, the schools are required. Like I think it's one of the safety precautions in any country, or even in South Africa, that if a student or a worker has to be engaged in any work that requires safety, you as an employer must provide the safety protective equipment. So it's the employer, or for colleges, it's colleges that needs to supply.
For me, I think one of the things that stands out is it isn't necessarily that we are going to produce entire sort of generations of programmers, but although of course there is a massive need to have people that are trained in this direction to be able to guide us through the future and produce what we need in the future in terms of coding and robotic structures and services in our lives. For me, it's about the fact that in the process of learning in these subjects, it's the massive amount of problem-solving skills that are built, and it's done very often in such a fun way, in such a challenging way, that it happens automatically, and it becomes a skill that is inherent then in the learner or the student that leaves the school or college.
Very important. For me, it's a way of life. It is the way we interpret the world. Yes, the world is gray areas, whereas robotics and programming and hardware is a black and white area some of the time. But at the end of the day, what we are trying to achieve is to understand the world. And we're currently in a space where autonomous work is becoming the norm. I mean, there's cars in California that drive themselves. We need to understand how they think in order to either avoid crashing into them or try to work with them. So we really need to understand the world and the way autonomy works on a different level. Even just the basic understanding, then we can say, you know what, that car driving there by itself, we should avoid that because that was made by a bad manufacturer who doesn't have good coders. It just, for me, it's a way of living.
Well, if we look at the fact that autonomy is coming into our homes, we already have vacuum cleaners that clean on their own, and so on. It is important that we'll have people that we can take it to who will be able to service it for us. And it's important that we have people that look at, I mean, if we look at what's happening on Mars at the moment, what happened with DART, that was just sent by NASA into an asteroid, things like that, we're going to need people who understand how this works and to understand how to develop robots even more, so that, because a robot doesn't need oxygen and doesn't need food, and if we can get that on Mars, maybe they can build another place for us to live.
I just want to go back to what Brian said, and we spoke about computational thinking. We actually only think computational thinking and problem solving is relative to programming, but this very skill is cuts across. So in a sense, we are improving on not just one sector, we're going to be improving many sectors with this problem solving and computational thinking. What we have been, yes, we've been using robots, we don't even know we've been doing it. I mean, programming your microwave and pressing, somebody has programmed that for you. But now I think we are looking with the coding and robotics, it becomes more evident that we are now making the world aware that we live in this kind of world. The rest of the world has moved forward, but now we as South Africans have to now move forward and go, keep with this world. There's so many exciting opportunities out there for children to discover other things to invent.
And for us to keep up with globalization and the rest of the world's trends and developments going forward.
Yeah, now where my subject comes in, or EDCR, every robot or processor needs an input and an output. And this is what we're going to teach. So that to make it a successful robot, if it hasn't got a good input and a good output, then it's useless. The other thing is every device, instrument, machine nowadays has got a microprocessor or some type of computer system in, and each one of them have to be coded. So there is opportunities out there.
Asif, I think since we are really now in the fourth industrial revolution, we can definitely say robotic and coding is of much importance, especially for our children to be taught at a very early stage so that they can be able to understand how to write a program. That program will be the one that will assist the robot to act in a particular way, because without a program, if a program is corrupt or maybe it's wrong, it's wrongly written, then the robot will not function in a way that it is designed to. So I think that's most importantly, students need to be taught how to write program correctly and accurately, and to be able to interpret statements as well, so that they can be able to even design whether ladder diagram or whatever, that will be a program that will be done for in PLCs. So yes, it's a very much needed.
So that's all the time that we have for today's session. I'd like to thank each and every one of the panel members for sharing your thoughts on coding and robotics in education, as well as in industry, and skills that students will have to eventually acquire moving into or being part of the fourth industrial revolution. So thank you very much for your time, and have a good afternoon further.